Hello everybody, my name is Frank and today we're going to talk about the midpoint and distance formula. I'm wearing a hat today because right now nobody can get a haircut, and also Miss Jennifer said that it would be better for me to wear it backwards than forwards, so you can blame it on her. Okay, so anyway, what I have is the midpoint and distance formula. So I've done some drawings for you. So I want to give you two formulas today, but I'm going to talk to you about how you get them. They're not just magic. So we want to talk about how they come about. And then we have about 3 or 4 problems to do. And then we have an extra for experts, which I know is you. So you want to stay tuned for that. So let's do the midpoint formula. Now, if I said to you, you have 2 grades in my class, what's your average? Most students know how to do that. If you have an 80 and a 90, you would say 80 plus 90 and divide it by 2. And you would say, okay, 85. Well, the midpoint is the average. If you were to drive from town A to town B, you would stop halfway between. So the distance from where you start to where you stop would be the same as the distance from where you stop to where you end, the midpoint. So if you look at this picture right here, if I were to go from this point to this point, where's the middle? You would say it's somewhere around there, which I agree. But precisely, where is it? Well, you average the 2 grades. But this time you average the x's. So how do you get the average? You add your 2 grades and divide by 2. So you add your 2 x's, x1 plus x2, and you divide it by 2. That would be the midpoint for the x. Now, you add your 2 heights. You add your y1 and your y2, and you divide by 2, and there's your formula. So the midpoint would be somewhere around here, but with this formula, there would be no guesswork. We would know exactly where it is. So this is a formula I want you to understand, hopefully put in memory, but if you ever forget it, you remember it's the average of the x's and the average of the y's, and you'll probably be able to derive that concept on your own. Now the distance formula. If I ask you to go from this point to that point, it's interesting. I will ask people different distances in sports that they've played all their lives, baseball, football, soccer. So, Mr. Ray, I never thought about that, how to find them distances. Of course, in so many sports, you run diagonals. So how far would it be from this point to this point? So we want to find that whole length, that distance. So let's put it D for distance. So what we're going to do is we're going to form a right triangle, and we're going to go down here and draw a line that touches that point that's parallel to the x-axis. And we're going to go across. And then we're going to draw a line from this point down that's parallel to the y-axis, like this. And if we did our job right, that's a right angle. Now, I wonder how many could tell me the coordinates of that point. And I've had students say, well, let's call it x3, y3, but that introduces another variable. So let's look at it. How far over did I go to get to that point? I went the same distance over to that point as I did to that point. So if you go the same distance over to this point as you did this point, this would have to be x2. So we know that this point is x2 over It's the same distance over as that point. And how high is that point? It's the same height as this point. It's that distance, which is y1. So we came up with the coordinates of this point without having to introduce more variables. So now we got to find the lengths of each side. Now look, how far is it between these 2 points? Well, they have the same height. So if I were to find this length, I would just take x2 minus x1. Okay? How long is this side? Well, since they have the same x coordinates, it's just y2 minus y1. So there we go. We have the 2 sides of a right triangle. The Pythagorean Theorem said if we square this leg, plus the square of this leg, that's equal to the hypotenuse squared. And now our goal was to find d, so we take the square root of both sides, and we have our distance formula derived. So hopefully you will memorize these in time. But if you ever forget them, that's how they're derived. And most students have told me after the fact that they would like to see how things work rather than just put up there to say memorize. So we're going to use the midpoint and distance formula to do our few examples. So let's look at the first example. The first example states that you have point A, which is -4, -2, and you have point B, which is +3, +3. Now, what's the middle? Well, if you're to randomly guess, I'm not sure. You would say somewhere around there. Let's use the formula. So the midpoint would be, let's call midpoint M. Now, how do we get it? We added the x's. It makes no difference in which way you will add them. If you go into the store and buy 2 grocery items, it's the same way no matter which order they ring them up. So you could put this first and this second, or this first and this second, but you just add them 2 x coordinates. So you have -4 plus 3. And you average them by dividing by 2. And you likewise do the same for the y's. You add them 2 y's. And you get -2 plus 3, and you divide it by 2. And what do you get? You get -1/2 and +1/2. So somewhere around here would be the midpoint. So that's our first example. You add the x's and divide by 2, and you add the y's and divide by 2. Our second example is a little bit more intuitive, and I'm going to show you 2 approaches to this. I'm going to show you strictly the algebraic approach using the formula, and then I'll show you another approach, which a lot of students say that makes more sense, the geometrical approach. Here is one endpoint, -5, 4. And there's the middle. So if you were going on a trip and your parents said, all right, we'll start here, we'll drive to the middle and take a break, and then we'll end up at the end. Where is the end? That's the question. Where's the end? You say, somewhere down here. So what do? We have the beginning point, and we have the middle, but we don't have the m value, which is somewhere the endpoint down here. We don't know what that point is. Well, we'll call it x2, y2. So how do we find it? Algebraically, we can find it. Now, what did the midpoint formula say? You average the x's. So you'd say x1 plus x2. And you divide it by 2, and what do you get? The x-coordinate of the midpoint, which is -10. Okay, so let's solve for x. If we cross multiply, this numerator times 1 is -5 plus x2. And this numerator times 2 is -20. And if we add 5 to both sides, we get -15. That's the x value. Let's do the same for the y. We take our y value, which is 4, add it to our other endpoint, which is y2, divide it by 2, and it gives you your middle, which is -6. And then we cross multiply. When we multiply 1 times this numerator, we get 4 plus y2. And 2 times -6 is -12. And we subtract a negative of 4, and we get -16. So our endpoint that we've just found down here, this point is x2, y2. Okay, now, some students like that approach. It's very procedural, very algebraic. Some students like this approach. If this is the start and this is the end, middle, how far do you walk from -5 back to -10? -5 to -10. How far would you walk back? You would walk 5 back. -5 back to -10. How far would you go down? From 4 to -6. Careful now. 4 to -6 would be down 10. So if that's the middle, then let's do it again to get to the end. Let's go 5 over. So that would be 6, 2, 3, 4, 5. So we would go 5 over, just like that 5. And we would go 10 down. So if we go 10 down, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would go 10 down. Missed it by a hair. And that would be the end point. Triangle's not quite lining up, but I think you understand the concept. So let's look at it. how far did we go over? Okay, so our midpoint was negative 10. So negative 11, negative 12, negative 13, negative 14, negative 15. Bingo. And our disk is negative 6. And we go down 10, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15, negative 16. So, whether you like the algebraic approach or the geometrical approach, but I've seen a lot of people pacing steps to find the midpoint out in the fields in surveying. They pace the steps. I walk over and walk this way, walk over the same, this way, and find the other endpoint. So anyway, you take your choice. But you could do it both ways and decide which way is quicker for you. Because sometimes test or time and speed will help you. Okay, let's do our next example on the distance, the length. Now, we derived the distance formula, so let's write that up here for you again. And hopefully you can start memorizing this in time and applying it. All right, so which point do you want to be the first? Who cares? If you walk from point A to point B, or if you walk from point B to point A, you walk the same length. There's no such things as negative. All right? So no matter which one you subtract. So I usually just call this x1 and this y1 because that's the way they're listed. This x2 and this y2, but you can do what you want. And all you do is subtract the x's. x2 minus x1 and square. Add y2 minus y1. Now, if you use the other one, you'd have the same answers. If you subtracted the other way, what would you have? You would have 7 minus 0 plus 6 minus 2. Okay? So either one, what's it going to give you? If you subtract 0 minus 7, you get negative 7. If you subtract 7 minus 0, you get positive 7. And negative 7 quantity squared is the same as positive 7 quantity squared. And 7 squared is 49. So no matter which way you subtract, when you square it, you're going to get a positive 49. Likewise, this will be negative 4, or this will be positive 4. When you square the quantity of negative 4, or when you square the quantity of positive 4, either way, you get 16. And then your answer would be the square root of 65. Now, depending upon if you're in math class, if you're in an application, you have the square root of 65, which if you type it into your calculator, you'll get a little bit more than 8. So that's your distance formula. Very practical. Our last one may seem the easiest example, but sometimes it confuses. So I asked you to find the distance between A and B. So you want to find this distance. So you say, okay, so how do I do it? Well, I did this problem for a nice example in concluding this lesson. If you wanted to, you could call this point 0, negative 2. That's this point. And this point would be 1, negative 3. So 0, 2, 3, that should be negative 4. Yes. So if you use your distance formula, you would subtract the x's in whichever way you want. Be careful here, that's minus a minus. And you would get, let's write this out for you, negative 1 squared. Negative 2, this becomes a plus 4, which would be the square root of 1 plus 4, which is the square root of 5. Now, let's look at another approach on this question. This ties together the Pythagorean theorem. Let's draw a triangle. How far is it between 2 and negative, this 2 and this 4? Negative 2 and negative 4. Isn't this side going to be the number 2? 2 units down? And how far is it between 0 and 1? Isn't that 1? So let's use the Pythagorean theorem in closing on this. You would say 1 squared, leg squared, plus leg squared is hypotenuse squared. And you would have 1 plus 4 is d squared. And 5 is equal to d squared. And taking the square root, you get d is equal to the square root of 5. So hopefully you're seeing the Pythagorean theorem, the distance formula, it building, and the beauty of it, no matter which way you approach it, you get the right answers. Now, take a break and we'll do our extra for experts. Just a second. All right, I hope you've had some spinach and you're ready for this extra for experts. Okay, here's a triangle. There's 3 points. A, 2, 1. B, 4, 0. And C is 6, 5. Find the perimeter. You've measured them 3 sides and add them and get it to the nearest hundredth. Okay, so how do we do it? Well, we find 3 distances and add them. So here we go. We're going to call this distance 1. So what 2 points do we find the distance between? 2, 1 and 4, 0. That's going to be distance 1. So let's do this. We subtract the x's, no matter which order you want. So you get 2 minus 4, and you square it. And you get 1 minus 0, and you square it. And then you get negative 2 squared plus 1 squared is the square root of 4 plus 1, which is the square root of 5. Okay, let's put a box around that. That's the first distance. Let's find the second distance. So what's good about this? It's 3 applications of the distance formula. Hey, wait till I give you an octagon. There's 8 sides. That would really be cool. Okay, D2. Now what points are we using now? We're using 6, 5 and 4, 0. So we have x1, y1. x2, y2, and we do it again. So we subtract the x's. And this will give us 2 squared plus 5 squared, which is 4 plus 25, or the square root of 29. So let's put a box around there. So we have this side. Now, I tried to draw this deceivingly. Somebody might say, hey, is this a right triangle? Are you sure that's 90 degrees? I don't know. So we'll call this D3. Maybe it is 90 degrees. Maybe it's not. So what would D3 be? It would be the distance between A and C. So A is 0.21 and C is 6.5. And now we're going to find the distance between them points. So we call this x1, y1, x2, y2. And we subtract our x's. So our x's are 2 minus 6 squared plus 1 minus 5 squared. And we get our quantity, negative 4 squared plus a negative 4 squared. Which is 16 plus 16. Now, most people would add them up and get the square root of 32, which is right. But there might be someone who would say, simplify it. So whether you write as the square root of 32, or whether you write it as the square root of 16 times the square root of 2, or 4 roots of 2, they're both correct. So let's put a box around either one of them. I would choose this one. So what's the perimeter? The perimeter is D1 plus D2 plus D3. D1 was the square root of 5. D2 is the square root of 29. And D3, you could say the square root of 32 or 4 roots of 2. Now that's your answer. But the question stated, if the question had been stated, what is the decimal equivalent, then you would type that in and get a decimal. Okay? Now, I'm going to leave you on an interesting thought. You think that is a right triangle? If it is a right triangle, it would satisfy the Pythagorean theorem. So let's go back to the picture. And we found D1 to be the square root of 5. We found D2 to be the square root of 29. And we found D3 to be either 4 roots of 2, but I'm just going to write as the square root of 32. Is that a right angle? Let's check. If that's a right angle, then this side squared, this leg squared, plus this leg squared would have to equal that hypotenuse squared. And is it? Is the square root of 5 squared plus the square root of 29 squared, is that equal to or not the square root of 32 squared? That's the question. The square root of 5 times the square root of 5 is the square root of 25, or 5. The square root of 29 times the square root of 29 is 29. And the square root of 32 times the square root of 32 is 32. 34 is not equal to 32. So the conclusion is this is not a right triangle. Okay? So that means it's either an acute angle or it's an obtuse angle. All right, you will learn more about that in your study of trig as we proceed on. Hopefully you found this very good. I hope you liked the challenge, the extra for experts. Okay, stay tuned for the next one. Take care.